Do you have a WPF application and want to take it to macOS or Linux? Avalonia XPF is a binary-compatible cross-platform fork of WPF. It enables WPF apps to run on new platforms with minimal effort and maximum compatibility. With a few tweaks to your project file, your WPF app and all its dependencies are ready for testing on new platforms. Start your app transformation journey with a 30-day free trial. Head over to avaloniaui.net/Hanselminutes to get started today. That's avaloniaui.net/Hanselminutes. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Sai Srirampur. He is the CEO and co-founder of PeerDB. How are you, sir?
Good, Scott. I'm very glad to be here and excited about this podcast.
Yeah, thanks for hanging out. So, you actually used to work at Microsoft, but you've gone and started a company, and you're in the Bay there, starting a new company focused right now on Postgres. And it seems like Postgres is having a moment. The last 5 years has just been a huge growth time for Postgres. Why do you think that is?
Absolutely. I think a couple of reasons, right? Number one, I think Postgres has evolved in supporting like a plethora of use cases, right? Like maybe 8 years ago, Postgres was used more like as a metadata store. But now, it has evolved to support like a bunch of use cases, including like transactional, analytical, search. That is number one. Number two, it is open source. Companies these days like are looking forward for like software where there is no lock-in, right? Like this is with both like enterprises as well as like SMBs, right? And that's the reason there is like a big shift of migrations from Oracle and SQL Server to Postgres because of open source and the trust. That is number two. Number three is more like the community around it. As it's open source, like there is a lot of like, support communities and like, that is number three, which is like the community. And last but not the least is, it just works, right? Like it is super usable basically, right? And developers love something that is usable and that just works, Scott, right? Like that's the reason you're seeing this like, shift. And one interesting insight I want to share is like, even from just like from a finance standpoint, right? Like Postgres revenue has grown from 1% of Oracle's revenue 5 years ago to now 10% of Oracle's revenue. So from a popularity standpoint, it is the only database who's growing in like popularity. This is from DB Engines. Yeah, these are a couple of reasons why, Postgres is taking off. And I've been in this area for like 8 years now, and I absolutely love Postgres.
Yeah, I think that it just works. Like that kind of like advertising really can't be overstated. Like when I came up in the 90s, there was lots of database advertisements in the magazines, and you'd hear about this database or that database. But right now, everyone's moving to Postgres because it simply works. It really excels to like SQL standards, SQL standards, because the ANSI groups, the ISO groups basically have these core SQL specifications. And Postgres basically conforms to most of them. And I think that is part of its it just works mystique.
Absolutely. Yep.
Just out of curiosity, do you go back and forth on saying SQL or SQL? Because it seems like Microsoft people say SQL and non-Microsoft people say SQL.
It's interesting that like I do both of them, right? Like because I also come from like Microsoft, right? Like I worked for 5 years there. So maybe when I'm speaking to developers, I do SQL, but when I'm in a podcast, I say SQL, right? Like, so it really changes.
Yeah, I was wondering if we were going to be able to solve that problem today for the people, but it sounds like we will not be able to do that. So for a lot of people, Postgres is like at the core of their business. It's the number one place. It's either the authoritative source for their data or it's going to become the authoritative source. And I'm curious how people are moving their data into Postgres, because for small databases, I use like little client applications. And I do what's called left-hand, right-hand work, where I say input and output, and I run it takes 10 or 15 minutes. This is not big data movement. But for a warehouse or something like that, you're going to need to move data in, I assume, a more sophisticated manner.
Absolutely. So it really depends on like the type of the migration, Scott, right? There are offline migrations and there are online migrations, right? Offline migrations are migrations where the application can afford downtime. These are like say tier 3, tier 4 kind of applications. But then you have online migrations where you want to minimize the downtime as much as possible, right? Like keep it to like say few minutes or like even seconds. And the tool depends on what is the type of the migration, basically. If it's offline migration, Postgres comes with like PG dump, PG restore, which is pretty incredible. I mean, it does like migrations at a snapshot level. It has like a bunch of options where you can configure parallelism. You can configure like the format of the dump, which is like you want it compressed or you want it like with plain text, etc. Right? So that is one which works pretty well for like, offline migrations. And then for online migrations, Postgres has this concept of logical replication, where you have the ability to take a snapshot in time and then read the changes in the transactional log periodically, and then make sure that the target, which is Postgres, is caught up, basically, right? And here I'm talking about mostly like, Postgres to Postgres migrations, right? Like you're running Postgres on premise and you want to move to the cloud. So PG dump, PG restore is for offline migrations. Logical replication is for like online migrations. Now coming to, if the targets are like heterogeneous, right? Like say I have like oracles, right? I want to migrate like Oracle to like Postgres. And it is pretty common these days with like enterprise like companies who have like a fleet of Oracle databases, right? These are like hundreds and thousands, and they want to migrate them to like Postgres, right? Like, and I saw this very closely at Microsoft. There are a bunch of tools, right? Like for example, Azure has this thing called Azure DMS, and AWS has AWS DMS. There are other like tools which help online migrations as well as offline migrations. And they also use a similar concept where if it's online, they use the transactional log, right? Like where they take the initial snapshot and periodically like, capture changes, which is also called as change data capture, and then put it to Postgres, basically, right? So this is about, how customers can migrate to Postgres, Scott, if that answers your questions.
Well, let me ask you this, maybe for the audience there, which could be a moment where we talk about the difference between a migration and a replication, because there's like a moment in time snapshot, but then you called out logging and change logs, which I think is an important differentiation.
Correct. So in migration, there is like a concept of initial snapshot where whatever data is currently present in tables, you put it to like the target database. Say you have a terabyte of data, right? Like already present in your source like database. You take a snapshot and put that terabyte like into the target database. Then while this is happening, you basically capture all the changes in the transactional log, basically. And then the replication process reads the transaction log. And there are different mechanisms, like each database has its own thing, right? Like for example, Postgres, it's logical decoding, right? Like Oracle has a different thing. The replication part is like it reads these transaction logs. It's a bunch of inserts, updates, and deletes, right? And then it applies it to the target database, right? So, and this is a part of the migration process. Now, interesting thing you bring up is there are a bunch of workloads where it's not like you just migrate like once, right? Like you want to keep a couple of databases in sync all the time. A good example there is, say you have like an operational OLTP database, which is Postgres, and you have your banking application running on Postgres, and you want to offload like a use case, which is fraud detection, which is more falls under the analytical bucket, to warehouse or an analytical store, right? Say Snowflake, right? In that scenario, you want to keep the operational store, which is Postgres, in sync with the analytical store as fast as possible, basically, right? Like with low latency, right? And there you want to keep it in sync all the time, basically, right? Like, and the latency requirements really depend on the use case, right? Like if it's like a fraud detection use case, the latency is more like I want it within few seconds, right? But if it's more for like offline analytics where I have my warehouse, I get data from like multiple sources, hours of like latency is also fine, right?
Yeah, this is a really great point that you're calling out, because so many people just love to say real time. They're like, I need this done in real time, but it's never really real time, right? If I have, shopping cart data about how my sales are going, and then I have a report, which is going to be real time in the sense of within seconds, I want to see inventories updated. But then I'm going to do sales reporting for the quarter. That's going to be a different database, like you point out. It's going to be a replication. What is your freshness guarantee then? It could be 30 seconds, but it could be a couple of hours. It really just depends on how much money you want to spend. I assume more money, more freshness.
100%. And that is not only for the replication tools, but that's also for the warehouses. For example, Snowflake charges based on how active is the warehouse, right? So the more real time you keep, the more costs you would incur. So you're right, like more the latency, more costs.
If I was going to do a one-time migration with no need of freshness, if I'm doing a hobby project, there's lots of tools that'll let me do that. Dozens of them. They usually have PG something, PG loader, PG chameleon, PG this, PG that. There are all different ways to get my data into Postgres. But if I want like to move data into Postgres to and from, That's where you thought there was an opportunity here and you started a whole business because you think it's so important. This deserves its own focused business.
Yeah, awesome. So at PeerDB, what we are doing, Scott, is like we are building like a first-class data movement tool for Postgres. And what I mean by this is like any use case that involves moving data in and out of Postgres, we want to provide like a fast, native, and a cost-effective like tool to make this happen. And a tool that scales, right? Like that's also very important. Let's get into like what are the use cases where like, customers like move data in and out of Postgres, right? Like first is we talked about migrations, right? Like where, okay, I have a fleet of Oracle databases and I want to migrate to Postgres, right? Like that is one. Next is you have getting data into Postgres. Another use case is Postgres has this like PG vector extension, which lets you store like embeddings and do vector search, right? Like in this use case, you basically have like unstructured data stored across multiple data sources and you want to, create these embeddings in real time and keep it in sync with like Postgres, right? Like you want to do transformations where you convert this unstructured data to embeddings and put it to like a Postgres for like, vector search, right? Like this is number 2, right? Now let's get into like use cases where you move data out of Postgres, right? Like it is what we talked about, the fraud detection use case where you have a warehouse or an analytical store where you replicate and keep data in Postgres in sync with like a warehouse like Snowflake or BigQuery. That is number 3, right? So across like, all these real world use cases at PeerDB, we are building like a tool that just works. I mean, this ties into like what we discussed before, where a tool is like, it's fast, it's like, native, right? Like it supports like, native Postgres features, right? Like say data types, right? Like you want to move like data types in a very native way. Say I have data types in Postgres, which are like arrays, and I want to translate and I want to replicate them to arrays in like my target, which is Snowflake. So fast, native, and last but not the least, cost effective, right? Like I think that angle is also very important because one thing that we hear from customers is existing data movement tools are very expensive, right? Like, so one angle we want to go after is also commoditizing data movement, right? Like why, existing data movement tools are like very expensive. That is also one thing which we are thinking of, right? Like, so a fast, native, and a cost effective way to move data in and out of Postgres defines PeerDB.
When you say that it's faster, and this is my ignorance speaking, like you have said on the open source repository for PeerDB that it's 10 times faster than existing tools. Like that seems impossible. When you talk about an order of magnitude faster, how do things get faster? Is it a protocol level? Is it CPU bound? Is it IO bound? Or is it all of those things?
That's a great question, right? So I'll give a couple of examples to, answer this question. So let's take pgdump pgrestore, right? Like a utility which helps you migrate data from a Postgres database to another Postgres database. Let's talk about PeerDB, right? Like let's compare like both of these, right? Like one feature that PeerDB does, which is not present in like pgdump pgrestore, is something called as parallel snapshotting, right? Like, so what we do is we basically logically partition a large table based on tuple identifiers for Postgres. These are like, identifiers which represent data directly on disk, basically. So we logically partition it and then stream these partitions in parallel to the target database, right? So this would like boost performance by orders of magnitude, right? Say you have a terabyte like of Postgres database that you want to migrate to like the cloud. If you were using pgdump pgrestore, it would take like a couple of days. But with PeerDB, because of parallel snapshotting, because of parallelism and also directly reading from disk, this would be more like an hours of time, right? And this would save like, the amount of downtime also, right? Like basically, because if you're doing pgdump pgrestore, you need to take a downtime of like 2-3 days. But then like if you were using PeerDB, it would be few hours, right? And this kind of translates to other use cases also, Scott, where like you're replicating data from Postgres to Snowflake, right? And the initial snapshot will be a critical part, right? Currently, our customers with existing tools wait for 4-5 days for the 5 terabyte like Postgres database to be replicated to Snowflake. But with PeerDB, that comes within a day, basically, right? So this is one feature where like we give this performance.
How do you balance you've started a company, but you have an open source project, you have a cloud offering coming. When you do this open source for an open source database, are you concerned that someone's going to take your kind of secret herbs and spices and move it into their own thing? Like, how do you keep the value? How do you keep the light on while presenting such a huge amount of value for like 10x performance gains?
My roots are from open source because like I worked at a database startup called Citus, which was open source, which got acquired by Microsoft, right? Like, and in Microsoft, I was in the open source like databases team. That is number one. The second is even my co-founder comes from like an open source background. He was like the 9th largest contributor of Flutter, which is like a huge open source like repository, right? So the reason we chose open source is because if we are building something around Postgres, it has to be open source, right? Like that is what like the community prefers, and that is the way we also like operate. That is number one. Number two, like obviously we are running a business, right? Like, and it is important to make money. For that piece, right? Like we have like a managed offering where we make it super easy to like deploy and manage PeerDB. We believe that like that will be important for customers who run workloads at scale and in production, basically, right? So with open source, that would take like few months of effort, right? Like to deploy, to set up and manage. Whereas with the managed offering, it's like more simple. And the reason it's like open source takes few months is because of the nature of the problem, Scott, right? Like, I mean, we are like solving a problem which entails scale, right? Like we are solving problem for customers like who run Postgres at their heart of their data stack. They have like tens of Postgres databases, or like they have terabytes of like Postgres data, right? So from a revenue and a finance standpoint, I consider open source to be more like a trust builder, right? Like than, a threat. That is number two. And number three, in regards to getting worried about like other competitors would use the magic sauce, etc. I think that I always believe that like, we are building this, I do this like 24 hours a day kind of a thing, right? Like similar with my team, right? And we are less worried about that, because if someone is they cannot do as good as a job as us, right? Like Scott. So these are the reasons like, we chose open source. One is, trust. Next is, it won't be a barrier for our like revenue, etc. Rather, it would be an enabler. And third is, we are not worried that another player would take this and like, run this on their own, because as we're doing this all the time, we will do a better job at it.
Yeah. Was it hard to pick Postgres as the center of the hub? Like you're not a generic, maybe I'm speaking wrong here, but you're not a generic data mover. You're a Postgres focused data mover, but you'll go to Kafka, you'll go to Event Hubs, you'll go to Snowflake, you'll go to BigQuery, but you didn't go many to many. You know what I mean? You went one to many. Why Postgres? Like we talked about why it's popular. Was that a hard decision, or do you think you'll go many to many someday?
We want to build a data movement tool whose focus is quality over breadth, Scott, right? Like I think that is one important like premise on which like PeerDB is built. That's the reason, any connector we build, right? Let it be the source or the target. We want to provide a connector that works with at scale, basically. That's the reason, we are like building for Postgres, because that's where my background lies, right? Like, and also there is a need, right? Like, because we talked about this, right? Like Postgres from a scale standpoint, from a use cases standpoint is growing, right? Like the amount of data being stored and moved through Postgres is significantly growing. That's the reason we started with Postgres. And then, down the line, if you ask me whether we will expand or not, our plan is to like nail like the Postgres data movement story, right? And we believe that like this peer-to-peer architecture that we're doing, where like we take two data stores and provide like the best possible experience, can be expanded to like other operational data stores as well. We go into like MySQL or like MongoDB, etc., etc. So this is one new thing that like, we are defining, where a data movement tool should be built with a peer-to-peer architecture than a hub and spoke architecture. Peer-to-peer architecture is more like you take a couple of data stores and provide like the best possible experience. Then, you focus on more breadth, right? Like where you convert like data from all these sources to a common format, you lose out a lot and won't be that reliable, right? So this is one thing that we are defining with PeerDB. Down the line, once we nail Postgres data movement story for Postgres, we will expand to other operational stores as well.
That makes sense. It seems like it's a good place to start, though. Like you are you're an ETL tool for Postgres, and you're also implementing stuff at a native level. Like this is not a generic.
Correct.
Like when I do data movement, it's usually a for loop. This is using native infrastructure optimizations that are specific to Postgres. Like that initial load is parallelized and the things that you talked about. One of the other things that I find really challenging is fault tolerance. Like it's bigger than just retries, isn't it?
Yes, it is bigger than retries, and that is one very important thing. For example, in PeerDB, we have like a state machine which makes sure that if something fails, right, like say the source crashes, or like, PeerDB crashes, right, like it can happen, or like the target crashes, right, like we auto recover, right? Like for this, like there is a robust state machine. For example, in our parallel initial load, the idempotency is at a partition level, right? Like we move data in bulk, and if one of the things crashes, we don't start the entire thing again, right? Like we keep track of, okay, what partitions have been done, what partitions have not been done. And then, like we have auto retry mechanism, and we use this like open source tool called Temporal, which helps with this. So that is also one thing which makes it like fault tolerant and like, has auto retries, etc. And that's the difference between like a tool and a platform, right? Like, I mean, here, like, we are building something that works in production, basically.
Interesting. So Temporal basically includes things like durable execution, abstractions, and things like that. Recovery logic, all that stuff is built in. So are you building on top of that open source project to make your execution durable?
Exactly. So it's basically an orchestration tool. So it lets you like define like activities, workflows, and all of that, right? So, but obviously we leverage Temporal. So we build on top of it, right? We need to define what are our activities, what are our workflows, etc. And then it has like mechanisms which will auto retry. Say an activity fails for some reason, right? Like say the source is down and like, the activity fails, right? Then it has mechanisms to retry basically. And this is one very core component of our architecture. Now, obviously, it's very I can go into like how, build stuff in Temporal, but
no, of course. But what I'm hearing you say though is that if you're going to do these kind of complicated workflows, if you're going to synchronize data, you're building on top of well understood concepts. You're not reinventing the wheel from a workflow perspective. And then you're using Temporal to capture those changes to the database, but then you're dividing up that process, that CDC process, up into activities. And that gives you kind of a more reliable data synchronization.
100%. And like, I'll be very transparent here. Like we had like a 5 minutes outage yesterday because of some reason where like IPv4, IPv6 transition, etc. And the beauty of like this state machine that we built on Temporal is it just auto recovered. So like we have like tens of like PeerDB instances running on the cloud, and 5 minutes there was an outage and it came up, and that didn't impact customers that much. The reason is because, the latency is 5 minutes is totally fine, right? Like, and then 5 minutes, like it came up, and because of the state machine and Temporal, it just like, continued from where it left off, and we didn't have to do anything basically, Scott. So this happened yesterday night. So I was awake till like 3 a.m.
But see, that's both, I'm sorry that you had a 5 minute outage, but also just the fact that we live in a world where you have to apologize for a 5 minute outage is surprising to me. But it's so cool when stuff like that just works. It kind of validates, it must be stressful because you were up, but doesn't it kind of validate your architecture? And you go, we didn't lose a byte. We didn't lose a row. And for 5 minutes, we had a heart attack, but everything is cool now, and it retried it, and it got it. And that robustness is there.
Exactly. We thought of it the same way because it was our first outage for 5 minutes, and then it really like, validated the design, right? Like, and then we were like looking at each replication job, whether this is like continuing, etc. And it was like, we didn't have no manual intervention, Scott. It just continued. So,
that makes me wonder if like things like chaos engineering and, randomly pulling the plug would be a good way to validate your design. I'm sure you do have, robustness tests and things like that, but this was your first battle tested production downtime for a moment there.
Exactly. We have those mechanisms where we do scale testing and where we bring things down and like, make sure that like it works. But then at a scale, right? Like, these were like multiple customer deployments, right? That were getting affected. So it was like more real than like our internal tests, Scott.
So it sounds like you're hoping that PeerDB is going to become a tool in everyone's toolbox, and it's going to sit alongside all those other great tools that people use. We think of tools like pgadmin and things like that, but Grafana and Tableau and all the different places that are consuming data, PeerDB will be in the center of that hub and start to move that data wherever it wants to be.
The place where we fit in, right, Scott? Like, the modern data stack, typically what happens is you have a bunch of data sources from which you move data to like the warehouse. And then in warehouse, like, you do your like transformations, etc. And you have like, Tableau, Power BI, and these kind of like tools which consume data from like, the warehouse. It could be like custom applications also. And then they do insights basically, right? So the way PeerDB fits in is the data movement piece, right? Like, so, okay, you have a bunch of data sources, but majority of the data to your warehouse is coming from Postgres, basically, right? Because that's your system of record. That's on which your business is running. That piece we want to like super optimize. We will be complementing other tools. A good fit would be a customer who is running Postgres at the heart of the data stack, and they move majority of the data to their warehouse from Postgres. That will be like a good fit for like PeerDB.
That's cool. And then from a data freshness perspective, you said it can be tens of seconds. Even at large throughputs, but it can also be, whatever you set. It really comes down to how hard you want to, how big the pipe is and how much data you have it coming in. Even if it's tens of thousands of transactions a second, you can keep, with that change data capture, you can keep things fresh.
Correct. Exactly. Right. Like, I think that really depends on the customer. The refresh interval is completely configurable, right? Like they can specify they want to do this sync every 1 hour or like every few minutes or every few seconds. And that is completely configurable. And this depends on the use case. Like we have a customer who is doing fraud detection for invoices, and then they, have it set to like more a minute basically. And then we have another customer who is doing it more for like, centralizing data from Postgres, and like they have offline analytics, they have machine learning jobs that are running. They, do it like every 2 hours. So that is completely configurable and editable also. So like once the replication job like starts, you can also edit this like refresh interval. If there are new use cases and you want it more real time, sure, like you make 1 hour to like 10 seconds.
I, as a small user, can go and try the open source product. I can do like micro, small amounts of data, but this could be used for, billions of active rows. There's no limit. That's so cool that I could use this on my computer, but I could also use the hosted cloud option to move billions of rows around at the same time.
Absolutely. And yesterday we were looking at how much data we moved in 3 hours, basically. Mm-hmm. It came to 3 terabytes. So in 3 hours, like across all the customers,
right,
PeerDB is moving around 3 terabytes, basically. So if you calculate like for a month, it would be like hundreds of terabytes, right? So the system we have designed works at scale, basically, right? Like billions of rows, like, terabytes of data, right? Like, so, yeah.
So that's pretty cool. People can check you out at peerdb.io. And they can try it for free. They can check it out. You can also go and get involved in the community. There's a quick start. There's also a link to the GitHub where folks can take a look at the source code and the build test that is up on GitHub. Thanks so much for chatting with me today and for sharing what you're working on.
Thanks, Scott. Like, thanks for the opportunity, and like, it's great chatting with you. So, yeah.
I've been chatting with Sai Srirampur. He's the CEO and co-founder of PeerDB. This has been another episode of Hansel Minutes, and we'll see you again next week.